In this video, we'll take a look at problem number 3 from Sinusoidal SHM problem-solving worksheet. Problem number 3 reads, the figure to the right shows 4 mass spring oscillators with various masses and spring constants as shown. Rank in order from highest to lowest the frequencies of oscillations. Okay, so they're asking us about the frequency of oscillation, so recall then that we will definitely be using the formula frequency is equal to 1 over 2 pi times the square root of k over m. This is the relationship that's going to tell us how the changes in mass and how the changes in spring constant will affect the frequency. So here we have oscillator A. It has a spring constant of 1k and 4m. We have spring mass system B with half of k, so the spring constant here is half the spring constant here, and the mass is 1m, so the mass is 1/4 of here. Part C, spring constant is again 1k, just like in A, but the mass is 2m instead of 4m. And then here in spring system D, we have 2k and a mass of m. So what we need to look at is how would these different frequencies compare to each other. So I'm literally going to write the formula for each one of these systems. So for system A, we would have a frequency that's equal to 1 over 2 pi times the square root of the k value, k, over 4m. So this would be 4m. This is essentially like writing 1 over 2 pi times the square root of 1/4 times k over m, which is the same thing as writing 1 over 2 pi times the square root of 1/4 times the square root of k over m. This is the term that's going to be important for us. System B, the frequency is equal to 1 over 2 pi times the square root of 1/2 k m. So we would have k over 2m. So that's the same thing as writing 1 over 2 pi times the square root of 1/2 times k over m, which is the same as writing 1 over 2 pi times the square root of 1/2 times the square root of k over m. Now, if you look at these two statements right here, you can see that system B is the square root of 1/2, and system A is the square root of 1/4, okay? Everything else is the same. Let's look at C. For C, the frequency is equal to 1 over 2 pi times the square root of k over 2m, which is equal to 1 over 2 pi times the square root of 1/2 times k over m, which is equal to 1 over 2 pi times the square root of 1/2 times the square root of k over m. B and C are identical to each other. B and C tie. Okay, B and C definitely tie. Okay. And then D. F equals 1 over 2 pi, the square root of 2k over m, which is equal to 1 over 2 pi times the square root of 2 times k over m, which is equal to 1 over 2 pi times the square root of 2 times the square root of k over m. Now, if you think about it, the square root of 2 is essentially 1.41. The square root of 1/2 is 0.71. Both of these have 0.71 ratio out in front of the square root of k over m. And the square root of 1/4 is 0.5. So that means the one with the highest frequency is D. Then B and C tie. Then A is last. So our rank order is D, B equals C, and A. Okay? That is ranking from greatest to least with the tie in the middle. And it's all related to this factor right here. Okay, that factor right there. Thanks for watching. I hope this helped.